near future, autonomous self-replicating robots could be the key to transforming alien landscapes into a second Earth. Imagine sending a fleet of these robots to Mars. Their goal: to kickstart the process known as planetary terraforming, turning the barren red planet into a thriving world complete with a breathable atmosphere, flowing water, and the potential for life. In this vision, each robot lands on the dusty surface and immediately gets to work, harvesting the Martian soil and minerals, creating more robots like itself. This army of robotic engineers works tirelessly, building infrastructure, regulating the atmosphere, and eventually paving the way for human colonization. This idea might seem like it's torn from the pages of a science fiction novel, but the reality is that it's based on principles of engineering, robotics, and space science that are being developed right now. Autonomous, self-replicating robots represent an intersection of artificial intelligence, additive manufacturing, and space exploration technologies that could revolutionize our approach to colonizing other worlds. These machines are designed to work without direct human intervention, using resources available in their environment to create copies of themselves, which then join the workforce in transforming the planet's surface. Let's break down the concept into its core components and understand how each piece fits into the grand puzzle of terraforming an entire planet. First up is autonomy. In the harsh environment of space, robots need to make decisions without waiting for commands from Earth, which can take minutes to hours to arrive due to the vast distances involved. This means they must have advanced artificial intelligence capable of understanding tasks, prioritizing them, and even improvising to tackle unforeseen challenges. Next, we have self-replication. The concept of a machine making a copy of itself is not new, but doing so in an extraterrestrial environment adds layers of complexity. These robots would need to be equipped with 3D printers or other manufacturing modules that use In-Situ resource utilization, a fancy term for living off the land, to extract raw materials and process them into working parts. These parts would then be assembled into new robots, effectively creating a self-sustaining robotic ecosystem. But how does this lead to terraforming, you ask? Terraforming is the process of modifying a planet's environment to make it more Earth-like. For Mars, this would involve a range of tasks from building protective domes to regulating temperature and managing the introduction of microorganisms that could eventually lead to the creation of a sustainable biosphere. Each robot would have specific roles, from builders and miners to gardeners and scientists, all programmed to work collaboratively towards the common goal of making the planet habitable. The implications of such technologies are profound. With autonomous self-replicating robots, the biggest limiting factor of space exploration, the cost and logistics of transporting materials from Earth become significantly reduced. By using Martian or lunar soil and rocks to build structures and machinery, we eliminate the need for expensive resupply missions. This not only makes the idea of space colonization more feasible, but also accelerates the timeline in which it could happen. Yet, with great power comes great responsibility. There are ethical considerations to account for, like ensuring that these self-replicating systems can be controlled or turned off to prevent unwanted ecological impacts, or the infamous gray goo scenario, where self-copying machines consume all available resources. Moreover, there is the question of planetary protection and ensuring we do not inadvertently harm any potential indigenous extraterrestrial life forms. As we delve deeper into this topic, we'll explore the current state of technology in robotics and AI, how additive manufacturing will play a critical role in in-situ resource utilization, and the scientific challenges of altering a planet's environment. We'll also consider the ethical and philosophical debates surrounding the concept of transforming other worlds to suit our needs. From the engineering feats required to create the first autonomous robot that can land on Mars and replicate itself using the red soil under its feet, to the far-reaching vision of lush green valleys and blue skies on a world millions of miles away. The journey of autonomous self-replicating robots for planetary terraforming is as exciting as it is monumental. Imagine the first robot, let's call it the Pioneer, landing on Mars. Its first task is to gather rock samples and analyze them for the essential building blocks it needs to create a second unit, which we will name the Pathfinder. Once the Pioneer has enough raw material, it uses an onboard 3D printer to lay down layers of regolith, that's the loose soil and rocks on the surface of Mars, to form the components of its twin. The Pathfinder is not an exact copy though. It's designed to be a miner, with drills and scoops to collect even more materials. Together, Pioneer and Pathfinder build another robot, and another, each designed for a specific task in the terraforming process. Some are builders, constructing habitats and greenhouses. Some are chemists, tweaking the Martian atmosphere, releasing oxygen, and, over time, warming the planet. As the robots multiply and their work progresses, the once barren landscape starts to change. Domes rise, containing earth plants producing oxygen. Underground, ice is melted into water, filling artificial lakes and rivers. The robots' programming ensures they adjust their tasks as the environment changes, introducing bacteria that can survive in the still harsh but slowly softening conditions. Gradually, the robots build less and tend to the nascent ecology more, nurturing the growth of plants, managing water sources, and maintaining the habitats they've built. Over decades or centuries, the planet is transformed. What was once a lifeless desert becomes a world with a biosphere that, while not identical to Earth's, is a new home for life. This transformation is only possible because of the self-replicating robots. Their ability to work tirelessly to create copies of themselves, to adapt, and to overcome the unpredictable challenges of a new world. But let's come back to the present. We're on the cusp of such technological breakthroughs. In laboratories around the world, prototypes of these robotic systems are being tested. Autonomy is advancing through leaps in AI, while additive manufacturing is becoming more sophisticated, capable of using a wider range of materials. Meanwhile, space missions are bringing back data about Mars, about its soil composition and atmosphere, which feeds into the plans for these robots. So, let's take a stroll through the current state of autonomous robotics, a field that's seeing rapid growth across various industries. From self-driving cars to automated drones, robotics is permeating our lives. The technology that powers these earthbound machines forms the foundation of what we can expect to see in space. For instance, machine learning algorithms that enable a car to navigate city streets without a driver are not dissimilar to the algorithms that would allow a robot to navigate the Martian terrain. Yet, the challenges of space are unique, which means the robots designed for extraterrestrial environments have to be extraordinarily robust and resilient. They must withstand extreme temperatures, radiation, and the vacuum of space. They must be able to carry out repairs on themselves and eventually on each other. This requires a level of sophistication in robotics that we are just approaching. Additive manufacturing, often known as 3D printing, has progressed from a novelty to a mainstream manufacturing process. The latest 3D printers can work with metals, plastics, and even biological materials. Adapting this technology for use on Mars or the Moon means developing machines that can handle the raw materials found there, which is a significant but not impossible challenge. These 3D printers will be the heart of the self-replicating robots, the means by which they produce more of their kind and the infrastructure they will build. In-Situ resource utilization, or living off the land, is one of the most important aspects of making long-term space exploration viable. Rather than bringing everything from Earth, which is incredibly expensive and limits the scope of missions, using the resources found on the Moon, Mars, or asteroids reduces the cost and complexity. Robots that can mine and refine these resources are a crucial part of the puzzle. They turn the concept of distant, inhospitable worlds into places where we could realistically establish a presence. Looking at the bigger picture, the concept of transforming a planet is a staggering proposition. It's not just about the science and technology, but also the vision it requires, the willingness to think on a planetary scale, to plan not just years but decades and centuries ahead. So far, humanity's approach to space has been tentative, exploratory. Now we're talking about taking decisive transformational action, and that's a leap that will require more than just robots. It will require a collective will, a shared goal that spans nations and generations. This is just a glimpse into the world of autonomous self-replicating robots and their potential role in planetary terraforming. In the rest of this video, we'll dive deep into each facet of this incredible technology. We'll look at how these robots are being developed, the challenges they'll face, and the solutions being proposed. We'll explore the ethical implications, the safeguards that need to be in place, and the international agreements that will be required. We'll discuss how these robots could not only transform other worlds, but how the technology could change things here on Earth, revolutionizing construction, manufacturing, and how we approach environmental restoration. Join us as we embark on this journey, from the robotic workshops where the future is being forged, to the dusty red plains of Mars where that future could unfold, and beyond. It's a tale of human ingenuity, of daring to dream big, and of the relentless pursuit of knowledge that takes us to new worlds, both literally and figuratively. From the first metal part printed on Martian soil to the first breath of air produced by an artificial ecosystem, this is the story of building autonomous self-replicating robots for planetary terraforming. It's a story of turning science fiction into science fact, and it starts now.